Why is that the case? Well, again, it's because of our uniform experience. Our universal experience shows that specialized functions require rational foresight, design, and then an agency to actualize the design plan. And so when we observe such functions in play, we can be strongly confident that the active features, the parts, and the functional logic are present, even if we haven't discovered them yet. And so there's a kind of, in this use of functional logic to generate predictions about what might be out there, there's an implicit design reasoning underlying it. And even scientists who aren't explicitly ID friendly, maybe even if they're ID hostile, have used this mode of reasoning to make discoveries. And I think we can use it being explicitly ID friendly. Let me tell you just one more fascinating example of this. Watson, well, not so much Watson, it's Crick. And this is Crick's genius. He was, by the way, he's a code breaker in World War II, which I think is really kind of fascinating given the discoveries that he made. But you may remember his famous adapter hypothesis about the transfer RNA, about tRNA. And what Crick realized was that the chemical structure of the bases in the DNA were so different than the chemical structure of the amino acids that he didn't see how DNA could function as a direct template for the sequencing of the amino acids. So instead, he anticipated that there must be something that is adapting or translating that information. And so here was a quote from him in 1955. He says, "Now what I find profoundly disturbing is that I cannot conceive of any structure for either nucleic acid acting as a direct template for amino acids, or at least as a specific template. I don't think anybody looking at RNA or DNA would think of them as templates for amino acids. The chemical structures are just too different." And so he ends up doing this, he does this design triangulation. Here's how he reasons. We've got DNA carrying information, but in a chemically non-specific form. We have eventually proteins being built out of amino acids, yet the amino acids have very specific geometries. Therefore, he concludes, wrong way. Therefore, he concludes there must be a mediating or adapter molecule that exists, or rather molecules, that enables specifying that allows us to allows the cell to specify the information to pass from DNA to amino acids. And he predicts the existence of this molecule. And here's how he boldly triangulates. He says each amino acid would combine chemically with a specific enzyme with a small molecule having a specific hydrogen bonding surface, and would combine specifically with a nucleic acid template. In its simplest form, there would be 20 different kinds of these adapter molecules, one for each amino acid, and 20 different enzymes to help join the amino acid to their adapters. And he went on to describe how Brenner called this the adapter hypothesis. And so here's kind of how it worked. You got the nucleic acid, you've got the amino acids. We're going to just dial in on one, say valine, and okay, too chemically different to directly template. So we need an adapter. It's got to bind to the amino acid, or to the nucleic acid on one side. It's got to bind to the amino acid on the other, and it's going to need an enzyme to help. And for each one of the 20 different amino acids corresponding to the triplets, you're going to need a specific tRNA and a specific amino acyl tRNA synthetase. And he basically, in the 8th day of creation, Horace Freeland Judson said this was a spectacular piece of reasoning from pure functional necessity to the existence of an entity for which there was not yet a single thread of empirical evidence. And of course, the story is fascinating because he turned out to be right. What is also fascinating is that Watson completely rejected this hypothesis. And he said, and he did so on evolutionary grounds. He said, "I do not like the idea at all. More to the point, the adapter mechanism seemed to me too complicated to ever have evolved at the origin of life. It required multiple coordinated interactions of well, at least 20 different enzymes, 20 different tRNAs, the nucleic acid, and then the rest of the gene expression apparatus." And actually, Watson is right about this. To this day, there is no decent explanation, not even anything remotely plausible for explaining the origin of the translation system. It's a huge unsolved problem in origin of life research. This idea was much too complicated to be explained by chemical evolutionary theory. But Crick stuck to his guns on pure functional grounds, on the grounds of the design logic of the system itself, the information processing system. So even though Crick was explicitly a materialist, I want to argue that he was implicitly reasoning like a design theorist. Watson's biological intuition, however, was constrained by evolutionary assumptions, so he rejected the idea out of hand. He had to accept it once the molecules were found, but his initial reaction to this revealed that he was constrained by evolutionary assumptions. Well, let's not be that. Crick was better than his materialistic principles. I would say he was reasoning as an ID theorist, even though he didn't explicitly acknowledge that position. Now, the point is, well, of course, they found the transfer RNA and the proteins. Point is, that's just one logic, one way of thinking about design that can lead to testable predictions.